Imagine you have just been handed your very first case. You step into your new office, ready to get to work. Your boss gives you a single, incredibly specific assignment. You need to prove a rule. All ravens are black. To do that, you cannot just sit at your desk. You have to go out into the real world, gather physical evidence, and see if the facts support the claim. After all, a successful investigation relies on finding solid, reliable evidence to close the case for good. You grab your coat and step outside to begin searching for your very first subject. Almost immediately, you spot a bird flying overhead. It is definitely a raven, and it is completely black. This makes total sense. You were asked to investigate ravens, you found one, and its color matches the rule perfectly. Every time you see another black bird like this, your confidence grows. Direct examples build a rock-solid case. As you keep walking, your eyes wander away from the sky and land on a nearby tree, where a piece of fruit is hanging from a branch. It is an apple. It is green, it is clearly not black, and it is definitely not a bird. Let's apply a backward rule. We take your original assignment and flip it around to test it in reverse. Think about the logic. If all ravens are black, then anything that isn't black cannot possibly be a raven. That green apple fits this backward rule perfectly. It is not black, and sure enough, it is not a raven. You look down at the sidewalk and spot another random object abandoned on the ground, a single white shoe. You run the exact same test. The shoe is not black, and it is not a raven. It passes easily. Here is a core principle of formal logic. A forward rule and its backward version mean the exact same thing mathematically. Because these two statements are identical, any discovery confirming the backward rule automatically confirms the forward rule. So, according to strict logic, staring at a green apple and an old white shoe provides actual scientific proof that all ravens are black. That feels completely ridiculous. Your brain is likely telling you that something in this perfect chain of logic is broken. You have just stumbled into a famous philosophical trap. It is called Hempel's raven paradox. A paradox is what happens when you follow the rules of logic perfectly, step by step, but end up arriving at an answer that feels completely crazy. The catch here comes down to scale. There are only a small number of ravens on Earth, but there are billions and billions of objects in the universe that are simply not black. Because that pool of non-black objects is so massive, examining one green apple technically provides a tiny fraction of a percentage of proof. It is mathematically true, but so microscopic it means nothing to a human being. This exposes a major flaw in relying blindly on mathematical logic. If we ignore scale and relevance, the math leads us right off a cliff. This highlights the difference between how a computer processes information and how we do. A machine looks at a green apple and a black raven and counts them both as equal, valid data points for your investigation. But human beings are smarter than that. We automatically filter out the low-value noise so we can focus our attention on direct, high-value evidence. Navigating the real world requires us to ignore a mountain of useless facts every day, even when those facts are technically true. To be successful in the real world, you need to understand the rules of logic. But to actually get to the truth, you have to run those rules through the practical filter of human common sense.